Hey folks, check out this really interesting exercise. We need to find the area of this square in light blue. We have the area of this square, which is 5, and the area of this other square, which is 20. The first thing we're going to do, notice, is find the sides of these two squares. So you know that the area of a square is equal to the side squared. So we can replace this area of the square with the value we have here, which is 5. Alright, and what do we do to find its side? We apply the square root to both sides of the equation, and as you know, I couldn't care less about the properties of absolute values, so I'm not going to bother with plus minus. Just kidding, we only need the positive part, remember that. And don't tell anyone I said that. Alright, and here, by simplifying the exponent with the index, we get that L is equal to the square root of 5. Alright, so notice, Gendaya says, this is just apply the square root to the area and we have the side. So with this idea, we can say that this side of the square is the square root of 5, and this side is also the square root of 5, as well as the side of this square here. So this is going to be the square root of 20 here as well. Notice, for those they say the square root of 20, and here this part is also the square root of 20. Alright, check this out. We have a right triangle here with 90 degrees. Cool, right? So how long is this side of the right triangle? How about I tell you it's the square root of 5. How do we know that this is equal to this part here? Look, the side of the big square, of this big square, is the square root of 5 plus the square root of 20. Since we already have the square root of 20 here, we're missing this part, which must be the square root of 5 because it's a square and all its sides are equal. Everything clear so far, right? You haven't gotten lost and we're all correct. Now what we're going to do is apply the powerful Pythagorean theorem, because you know I love using the Pythagorean theorem in every exercise. Alright, so what we're going to do here is we'll have that the hypotenuse, let's call it h. From here to here is going to be h, which is the hypotenuse of this triangle here. The hypotenuse is going to be equal to the square root of one side squared plus the other side squared. Excellent, right? So we have that the hypotenuse is equal to the square root of this side, which measures the square root of 5. Square root of 5 squared plus the other side, which is the square root of 20. Square root of 20 squared. All this inside the root, remember, don't go doing something crazy here, right? So we already have here, add the hypotenuse. Note that the hypotenuse is the square root. And when we square a square root, the index and exponent cancel out, leaving the radicand. So here we have 5, and over here the same thing happens, index with exponent leaving 20. Very good. Alright, so what have we got? That the hypotenuse is the square root of 25, and as you know, the square root of 25 is 5. Wonderful, we've got the hypotenuse and the AKSP. And you're probably thinking what this is. What the heck is this for? But you'll see it measures 5. Excellent, right? Now we also know the length of the square side, which is the square root of 5 plus the square root of 20. We can write it differently. Look, we're going to add these two roots. And you might say it can't be done because they're different roots. But it can, see? The square root of 5 is the square root of 5. And the square root of 20 can be written as 4 times 5, right? 4 times 5 is 20. We take the square root of 4, which is 2, and we still have this root here plus over here, the square root of 4, which is 2. And inside the root, we're left with this 5 here. Amazing, right? Now if we add 1 square root of 5 plus 2 square roots of 5, we get 3 times the square root of 5. Amazing. So this part here is 3 times the square root of 5. Great. And here we also have 90 degrees because it's the angle of the square in blue. And again we have a right triangle here. And don't think I'm going to use Pythagoras here to get this side, because we only have this tiny part here. I'm not as dumb as you might think. So what we're really going to do is look at these two triangles here. One is going to appear in red and the other in blue, alright? Let's pay close attention and be very interested in these two triangles. We're going to move this triangle over here, but first, let's talk about the internal angles, see? Let's remember here that when we have two parallel lines, and they are crossed by another line, this angle here is equal to this angle here. So why am I explaining this to you? Because that's what we have here. This line here, I'm going to erase this triangle so it can be seen clearly, okay? Let's erase this and notice this line here corresponds to this line here. And this line over here corresponds to this line over here. As you can see, both are parallel lines, and this line crossing the two parallel lines is this line here, which is the side of the square whose area we want to find. If we extend the lines, it becomes clearer. See? If we continue like this, you can clearly see there are two parallel lines and one line crossing them. And we had said then that this angle here, which corresponds to this angle, is equal to this angle over here. Alright, now you know when we have two triangles and they share two angles, meaning the two angles are equal, this 90 and this angle 90 and this angle, the third angle, which will be this angle here, will be equal to the third angle over here, meaning this angle here. Great! Now we know that both triangles are similar triangles, and we will continue highlighting them. Let's move this triangle over here as we had it before, and we will jot down the information we have here. So this side here is the square root of 5. We have the square root of 5, the hypotenuse is 5, alright, and the base is the square root of 20. Fantastic, right? And now let's move the blue triangle over here, but it's not ideal to have it this way, so we'll turn it to the other side. So we erase it and it appears over here on the other side. We'll erase this here as it's no longer needed. Here we have the 90 degrees. Very good. Now the hypotenuse, which is this here, is 3 times the square root of 5. Alright, intricacy. Emphasis. Sandra, notice this part, which is the base of the triangle here. We will call it x. So the base here is also the base of the square, whose area we want to find. That is, it's the side of the square, the base of this right triangle. Alright, since since both triangles are similar triangles, we can directly relate their sides. We can say that x is to the square root of 20. Let's note it here. X is to the square root of 20 as this hypotenuse is to the other triangle's hypotenuse, which is 5m. Great, right? So we'll bring this square root of 20 to the other side to multiply. So we have the square root of 20 here, and we erase it from here. Alright, we have this equality, right? This equation will square both sides, square here and square there. Excellent. We have here x squared, which is equal 3 squared gives us 9. When raising the root to the square, as we said, we get the radicand, not the index. 5 squared is 25, just great. Here, the fifth root of 5 is 1 and the fifth root of 20 is 4. Since we've squared everything, we need to remove this square here. The fifth root of 20 is 4 and the fifth root of 5 is 1. Listen up, folks. By Newton's beard and the power of Grayskull, 9 times 4 is 36. And you might ask, what is this for? Well, this represents the shaded area. Because the shaded area is the area of the square, and this square is of side x. Remember, that was the side. So the shaded area is 36 square units. Fascinating, right? Let me know in the comments if you liked the video, and don't forget to subscribe and give a thumbs up so you won't miss the next challenges. See you next time. Bye bye.